Okay, today I'm going to be answering the question, is space cold? The reason I'm doing this is because I've had a lot of comments in the comments section talking about space because of how many vacuum videos I do. So obviously people think about space because space is a vacuum. So I want to talk about the temperature of space and what that even means and answer the question, is space really cold? Or is it hot? Or is it neither? Or what is it? First, I'm going to measure the temperature of space. And I'm going to do this by hanging a thermometer in my vacuum chamber, removing all of the air till it simulates the vacuum of space, and seeing what the temperature is. So you can see that this is just hanging freely, not touching any sides, so we're not measuring the sides of the chamber, we're measuring the space in between. Okay, let's keep an eye on this thermometer, turn on my vacuum chamber and see how it changes. So right now it's hanging out around 17 degrees Celsius. Okay, measuring the temperature of space. 3, 2, 1. Looks like the temperature's going down. Pretty quickly, actually. So after this is done, I'm going to explain why it's acting like this, and is this really the temperature of space? So we started at 17 degrees, we're at 13 degrees now, and getting colder. So it's starting to not drop as fast. Okay, we're at 11 degrees Celsius, 11.1 degrees. Not much happening now. Okay, we're at a pretty good vacuum at this point. It's climbing back up now. Okay, so what happened there? Why did that decrease as soon as I turned on the vacuum? So the reason it decreased right away is because it's filled with air initially, and then I turn on the vacuum and it sucks out the air and the air expands. But expanding a gas like that reduces the temperature, so the temperature of the air that was in there got colder. The thermometer picked that up and it showed it was getting colder. But after a while it sucked out all of the air wasn't expanding anymore, it was a really low vacuum in there, and eventually there was no more expanding gas and it was a pretty good vacuum in there, and there's nothing to dissipate the heat from the thermometer. And so the residual heat that was in the head here and some of the bar there eventually made its way back down to the end of the thermometer, and that made the temperature go up until it reached an equilibrium temperature of around 14.9 degrees Celsius now, because it lost some heat as the gas expanded. So that's what happened in the vacuum chamber with the thermometer, but does this represent the real temperature of space? So the answer to, is space cold? I would say the answer is no. Space isn't cold or hot because true space is nothing, and nothing can't be cold or hot, it's nothing. That's what we use in thermoses. So in insulative thermoses like this, there's a gap in there that has a low vacuum in it, and the vacuum in there is very insulative because there's nothing to transfer the heat through. And true space is just like this thermos here. It can't conduct heat away from you or towards you. But that's nowhere near the end of the story. If you were to go into space, you would for sure freeze if you had no heat generation. And that's because you have to remember that even though there's nothing to conduct heat away from you, you still lose heat. That's because you have to remember that every object is continually emitting radiation. That means it's emitting heat. But this is heat that's in radiation form, so it's photons leaving your body. And that's continually happening. But we don't really notice it here because you're continually emitting radiation and you're absorbing radiation. And so you kind of stay at this happy equilibrium. But in space, you emit radiation, but you never get any radiation absorbed back into you when there's nothing around you. And so you just emit radiation and you get colder and colder and colder and eventually freeze. And eventually you'll get to around 2.7 Kelvin in deep dark space. So that's only 2.7 degrees above absolute zero. So you would be very cold in deep dark space because you emit radiation, but you never absorb any radiation. Now, if you were closer to the sun, then it's going to be a different answer because there you would absorb radiation from the sun. Okay, now I should film what happens when I put the air back in. Okay, letting air back in the vacuum. 3, 2, 1. So it got warmer than it was before. So just the same reason that the temperature went down when we turned on the vacuum, the temperature increases because we put in air, and so that what was inside of there got compressed, and that heated it up and made the temperature go up. Okay, and if you're wondering why the temperature got higher than it was initially, I'm not exactly sure, but I think it's a complicated answer. I think it's because so I let it sit in there a long time when it was under vacuum. So the temperature eventually increased because either through conduction through the walls of the chamber or through the tape or even from the radiation of the room, increased the temperature of this a little bit. And then, so it increased the heat of the thermometer. And then when I lit the air back in, it compressed the air and it was able to get to a higher temperature because this had more heat in it than it originally did to begin with. Hey, thanks for watching again. If you enjoyed this video and you haven't subscribed yet, remember to hit that subscribe button, and you can comment in the comment section with what you'd like to see me do next, and I'll see you next time.